Now you can talk. Welcome, folks, to the first Hyperloop meeting. I forgot to record it. Now we're recording. So you only missed 50 minutes.
Sweet. Okay. Well, so I'm the first person talking at this meeting. I guess I was just having a little trouble picturing, like, with the size of the tunnel, using the tank, and then the cart system. I guess it's just a lot to piece together, but I know these are just like initial brainstorms. So just like a thought.
Yeah, we thought the tank would be external.
I'm gonna do that. Oh.
Sorry, got like family members. It's kind of crazy right now, but so tank would be external, so out of the tunnel, powering pneumatics inside the tunnel, and then this cart system. How would that cart system be working? Would that be like autonomous, like robot carts, or were you taking like a track, something like that?
My idea was essentially RC cars, like just a modified RC car. So, you know, electric, battery, easy potential to swap out a battery. And then they're kind of just, once they're in the tunnel, they're autonomous. And then maybe some multi-level mechanism at the actual borer where, you know, you have one waiting above, one loading below, and then you roll the one loading and then lower the waiting one on it. So then you just immediately can start loading again while that one trucks it out. And then by the time the one's finished loading, you're trucking back in already.
Definitely. It's definitely a lot more complicated than I guess I initially thought, because now we're talking like, if you're thinking multiple carts, you have autonomous systems communicating, they need to communicate with each other. And I guess I'm thinking from like a guidance perspective, and then you have these pneumatics being powered from a tank outside. You can't run into that pathway, and then it's just an interesting problem. And I guess I'm piecing it together now because I missed part of the conversation.
For autonomy, in terms of that, I was just picturing only one cart would be moving at a time, essentially. So then you wouldn't need to really worry about collisions within the tunnel itself.
Mm-hmm. Definitely, that makes sense. I guess one of my concerns would just be like riding along the walls, you know, and not getting stuck and things like that. But I mean, these are just problems that I'm sure you guys already talked about. But we can continue with the digging that was Dan was doing. But yeah, thank you for all of you for just catching me up. I appreciate it.
I'm going to interrupt real quick because I think I was thinking a little bit more about your idea, Cody, of having like a zip line. What if we could? This is a really shitty drawing.
Yeah, something that was exactly what I was picturing.
Yeah.
Like a two-way line of places.
Like a ski lift.
Yeah, exactly, a ski lift. And that way, I think we could design these such that right now I've got them kind of like hanging up in the air. What if they look more like bullets and they're able to just nudge past each other no matter what, and we somehow keep them from getting tangled with one another?
Yeah.
So
I was thinking of like instead of like them being built onto the line, it could be like containers that are on the digger that cycle through and like unload and get loaded back on, so it just cycles through on whatever line.
Yeah, I like the idea of having like the zip line pick up a container rather than having a permanently attached one.
Yeah.
Sure. Yep. I like that it can like clip on, clip off, just like a ski lift.
Essentially.
Totally agree. I think that would dramatically simplify ideas if we didn't have to worry about what's happening inside the tunnel. Yeah. And then, you know, on the offload station, what we're able to do is basically interrupt our loop and have it coil in a complex system, and we're able to just continuously feed more line as the system grows.
I don't think we need any I see, to extend the zip line.
Yeah, that was my kind of initial concern, that you just get stuck with, you know, like 5 meters versus 30 meters. It's a big difference, and you don't
I would say, just for simplicity reasons, just having the 30 meters at the start and just have it just be back 30 meters. And then if you can just clip off these parts.
Definitely. Yeah.
Well, you could have it taut on the digger and then have it something that like holds it in place to keep it taut, and just a whole coil on the digger just constantly like unravels while staying taut.
I would say just even have it permanently be taut, and then just have the unloading station be stationary, and have the like opposite post move closer and closer.
Yeah, I think opposite. I think just just doing this makes total sense to me. And if we are blessed with that much space, then go for it. But the other idea is that you can just loop line back and forth over the course of a meter, and then if you just move it a meter, you've just gained every little bit that you just compressed. So there's a couple of different ways to do it, and it's like there's a pretty simple way to overcome the difficulty of doing that. If we can just move 30 meters in and keep our line the same length the whole time, let's do that. But otherwise,
that's obviously a regulation thing that we just need to wait on.
Yeah. Okay, so then we've got these bullet pods. How do we keep them from getting tangled with each other? It'd be ideal if we can, instead of this being top bottom, assume that it's like lying on the ground or something, so that we don't have to support anything.
Yeah, I pictured, because from what I researched on the Boring companies, they have a very similar system, except just take a zip line and make it a rail, where it's just a constant loop of rail cars. Obviously, I don't think we have the room to do that. But what if instead of having the zip line be vertical, what if we just completely take it horizontal like a ski lift? And
yes,
just have
totally agree.
And keep the lines as taut as possible the whole time.
Then we wouldn't need to worry about turning the pods if we unload before the turn, or if we, remove the pod from the ski lift zip line before the turn.
Totally, yeah.
Just have like a clipping mechanism where it clips on.
Yeah, because I could picture we could even have these pods be wider or longer than the diameter of the tunnel if we avoid ever having to turn them. You see what I mean?
Yes. Yeah, they can be big. My concern is I don't imagine we're going to be able to go end to end with them, because I imagine this thing is, I guess you don't have to have it continuously moving. We want to reduce the amount of total pods we need, though, so we don't want to have 30 meters of line in, 30 meters of line out with pods every step of the way. That's just that's a lot of money that we just don't want to spend it on.
I pictured maybe hooks, or the pods can just hook on themselves at any point.
Yeah,
so you just have a line.
4 or 5 or something that are on our digger. And then
sure. What I'm imagining is we've got a pod coming in, pod coming out, and that if we're not careful, they can get crossed and snagged like that. So we got to make sure they stay on their respective sides of the tunnel, and that the ropes don't get crisscrossed.
I pictured rollers on maybe the sides of the pods, so that when they're coming close, if something happens, it has a roller, so then they roll to the proper distance.
I'd want to go simpler than rollers. I think if we're able to construct
I'm saying it's a fail-safe.
Dirt dynamic, not aerodynamic, but some sort of shape that keeps them apart.
Why I was picturing that the pod, we could fit 2 pods side by side in the tunnel. Do we not want to do that?
I totally agree. It's just we've got a circular tunnel. Maybe we're going to surface the bottom, maybe we're not. Either way, we need to end up with like the same equivalent area as half a meter diameter tunnel. So these pods are going to want to center themselves when there's no other pod next to them. So at that point, I think there could be a line crisscross, and then they could get snagged, which would suck because that would just end everything, I think. So we need to make sure that every single pass that occurs, they push each other out of the way on the right side.
Yeah, like
what if we avoid ever having a pass? Instead, maybe having just enough in waiting, or maybe sending 2 empty ones back, and then take 1 full one out, and just avoid ever having a pass.
Oh, yeah, like send 2 in and then 2 out. And then
I think
that'll probably slow us down a little bit.
Yeah, I think that would reduce our speed by more than would be good. If we're pigeonholed into keeping only 2 on the rail in the same direction at a time, then that's what we'll have to do. But it would be great if we could just run this thing super slowly, super carefully, and just continuously have a pod show up on time and then get hooked back on.
I'm just thinking if we want to maximize, the mass we're taking out at a time, and then especially considering, do we want, if we can have the line instead of completely supporting a pod, maybe the pods roll and the line's just pulling, kind of like.
Yeah.
Yes. Yeah.
They have wheels to pull.
Okay, that's where we're on.
Yeah.
And if you just have one rolling in there, and you're pulling, I think we can make it where we're continuously moving material without ever having a pass. I think it's possible.
I suppose the only thing we want to do is just make sure that we're not necessarily continuously. I don't remember the word you just used, but we want to make sure that a pod is constantly being filled. And I think we're on the same page there.
Right, yeah. If
it's not constantly being filled, that means that we're not doing this efficiently enough.
That's absolutely what sets the boring company apart.
Yeah, we want to be limited only by how quickly we're able to carve dirt out. So all right. So then that's our limiting variable right now, is figuring out how quickly we're able to dig. Because once we figure that out, if we're only able to dig a foot per minute, which would be very fast, then perhaps a single pod is all we need.
I'm thinking just, since we're using this zip line method, we're going to be able to carry way more mass if we don't actually have a driving motor in the pod. If the pod's just resting on wheels and being pulled along, I think we're just going to have way more mass available to move at a time. And so in that case, I think we might be able to make carrying an empty pod, it takes some time to lift the full pod out, but we can set an empty pod back in, I think, before we even fill another pod.
Okay. Yeah, I agree.
I think speed mechanism that we can just send it in with no concern of speed.
I think no matter what, so we have a pod filling, there needs to be a pod on the way. So presuming, I think 2 pods is required no matter what, because you've got a pod filling and a pod either departing and then arriving. So that's how long that process should take. So there's always a pod located there.
I was thinking 4 pods in total.
I don't even know if you need 4. Because, so let's say you're able to carry, a quarter ton, half ton of earth in a single pod. So you've got that current pod filling, and then when it comes out, it's heavy again, so it's on the floor. If your pod coming in order to get to the boring machine, just pops over the top of it, is yanked over the top.
I think when it comes to spacing, like, since it's a small space, we're not going to be able to make a container that will hold a huge amount of weight. So I think 4 is a good idea, because we'd be filling 2 at a time, and each has like a decent amount in it. But I mean, you need to have them smaller size for the space that is available. So you need 2 filling at a time and 2 leaving at a time, whereas 1 going at a time would probably not be enough. When it comes to
why 2 filling at a time? I don't understand why you want 2.
Yeah,
I'm talking about like in space of like the container size of fitting in the hole, like that we're digging. I don't think one would be enough to like carry a more efficient, like the most efficient amount in and out cycling. So I feel like filling 2 at a time, since we're gonna have like less volume of the container, and cycling them would be better.
Yeah, I think what I would say is that it's easier to fill 1 that's double the size rather than fill 2 that are half size. Yeah, I think that's a pretty easy trade-off, because you've got your tunnel diameter and you're able to determine whatever the heck you want your pod size to be. So I think a semi-cylinder is the shape that comes to mind for me. So it's like a trough.
We're just like restricted by the width of whatever container. Right?
Just a consideration that I didn't really think about until now. If we're having a line pulling them, there's going to need to be some tension pulling on our actual borer.
Yes. The boring machine will already be presumably very heavy. I think we can have, I think you're right about there needs to be some sort of way of reducing friction on the bottom. Like maybe we put them on skis, but I think even like non-powered treads, so that you've got like just like a tank tread, except instead of, so just tank treads with no motor on them. That's what comes to mind to me.
That'll help keep the lines from tangling too. If we do want to like have a continuous cycle, like having them on spaced rollers, keep them like spaced out and like set onto the ground.
Yeah, I suppose I don't quite know how you keep them spaced out. How does having tank treads help you keep them spaced out?
Well, I was thinking of an idea of like a roller on the top and bottom that both like touch the edges of the tunnel, and they roll across the tunnel while it's like in the middle or something like that, and that'll keep it like in place as it's going.
I don't think we'd be able to enclose the pod. I think it's better just to have an open pod.
Yeah, I think so. If you take a half cylinder, if what we're dealing with is a half cylinder, so it's just a trough, you fill that up and it's coming out. So then the only way to get over that is to go over the top of it. And if you've got an empty half cylinder, then you're able to just flip that upside down and come over the top of it, which is still annoying, but not impossible.
I just don't see room for. We have to consider that if we're doing a wheel that's the full size of the tunnel, where would we put a loading mechanism? I was thinking of having a smaller wheel that maybe only takes up a quarter of the tunnel, and just having it be able to latch on to either the top section or the bottom section of the rope to change direction.
Yeah, I don't think there's going to be a top and bottom. I think they're both going to be lying on the tunnel floor, and the only side that should experience significant tension is the one that's pulling out the loaded dirt.
Like having the wheel that's actually running the line be vertical. So then there's a top and bottom section, so it's still in line, so you can just latch on whichever one you want to go in which direction.
Okay, sure. I like the idea of having a more of a slack line version where you don't have to have tension, because if there is any sort of turning, if for some reason we need to dip down, dip up, then that wouldn't be a deal breaker. Yeah, I would still make stuff difficult though. In order to, this is something I'm just going to throw out there. So imagine we have to pass around a corner for a second. We're going to have a taut line yanking into the corner, which is going to be awful. But you keep on pulling and pulling. You can't have your line far away from where your wheels are, because you're just going to get yanked until you're jammed in the tunnel. Yeah. So when you've got a loaded pod, you definitely need to be pulling from like right where the wheel's located. I think that keeps you from getting snagged. I think that's the lowest probability of getting snagged if you pull from wherever the treader wheel is located.
Yeah, I see
that. I think whatever system we design, I think it's going to be something more along the lines of, we've got like not necessarily knots in the rope, but just fat bulbs that you're able to hook onto, rather than imagining some sort of complex mechanism for the pod to kind of grab onto it.
Right,
I think we just want to snag it and then just pull it along.
Yeah, it's like loops to like hook onto. right?
I don't even think loops. I think like if you see those power lines with like what looks like a basketball on them, something along those lines, where it's just like a ball or a bulb that, you know, kind of gets, you know, the line's passing through some sort of triangle, and now you're just caught.
Yeah, it has like a little loop, and the pods can have like a little hook that just like catches on that little loop.
Have you ever been like inner tubing down a mountain? Because they got like a continuous tow rope going with a bunch of hooks, and they just hook your line on the rope, and then it yanks a tube up at a time. So there's no, you know what I mean?
Yeah, I think we're all kind of talking along the same lines. That's whatever system we come up with, though, I think is able to just come up with the simplest thing possible. The other thing that comes to mind for me is The Dark Knight, where he sends up the balloon after he captures the Chinese businessman, and the plane comes along with a fork and hooks it. That, I think, gives you the widest margin of capture. Definitely more discussion to be had on that, but I think that is that sounds right to me. Okay, so now we've got these pods that need to be designed. We've got this rope system that needs to be designed. We haven't really talked about cutting. We haven't talked about what's going on with the pod and power. How much time does everybody have? I think I'm going to do a hard cutoff at 6:30. But are people good for the next 15 minutes?
Yeah.
Okay.
Should be good.
Cool. 6:35. All right. Let's talk a little bit about digging then. We kind of just moved away from it because it seems to be the thing that we don't really want to talk about for whatever reason. So my idea is that you've just got you've got a steel plate that's welded onto the front of your guy. You've got some pneumatic pistons that are pushing it along like a train. And then it's got little cup-shaped grooves that just spiral outwards from that center piece. And they just cut out grooves as they pass through the dirt.
I think the traditional mechanism is going to, I'm just thinking, you know, like the boring company came out here and, you know, tried to completely redesign tunnel boring.
And they came back to the same thing.
Came back to the same thing. I think it's just one of those things. It's like the wheel, you know, it's like it's the best there is. Yeah,
I like that it's continuous. I think it's also pretty easy to power pneumatically. Definitely something to think about. But, you know, like trains have run on hydraulics / pneumatics / steam power forever. So that same sort of idea can definitely be applied.
Sorry, just to clarify real quick. So when you say, I think you said the word pneumatics, you were thinking like train, like driving structure. So like that would be moving us down the tunnel, and then the digging mechanism would be powered off that same system?
So when I say pneumatics is just, I'm just referring to air-powered systems. So this tank is pumping air into cylinders that are expanding and contracting, depending on how you've got your valves open. Just like on a train that, you know, goes like this to power it, we'll be able to employ a similar system. The other thing that kind of does this is airplane motors. You're able to see it way more than in a car motor, but the pistons create this kind of, well, they create the rotational motion that you see the propeller demonstrate. So that's kind of where I'm thinking for how you power something like this. And you're easily able to get hundreds of foot-pounds of torque, Newton meters, whatever unit system you enjoy. Then the other question is, how big do you want those scoops to be? So the bigger they are, that means you're able to handle rocks, but the bigger they are, way easier it is to get jammed on something. Yeah, I mean, that's the trade-off there. you get to take out really huge chunks if you've got big scoops, but you also get snagged easier.
I think that'll depend on like how much power we're able to put into it, like how much torque we'll give. I think that's entirely dependent on that.
Yeah. I think some initial experimentation is probably called for. I think that we need to come up with some way to kind of test some models. So 3D printing is what comes to mind. And then like an egg beater or something. You just attach it onto the end of an egg beater and then just kind of rip it around in some Play-Doh and see what happens.
Yeah, we could easily standardize a testing size.
Yeah.
And then have like an egg beater style thing like mounted to that. And just a testing rig and just keep printing out different, or even just print out the scoops and have them just attached to this testing rig.
Yeah.
My head just kind of goes to, sorry, don't mean to cut you off, Dan. Just like rocks, like, I don't know how much of that was covered before, but just like big rocks, like how you, because obviously, you know, as you mentioned, the bigger the scoop, the more you can pull, but if the rock is bigger than the scoop, I just don't understand what you do.
Yeah, I think our operating assumption is that there's no such thing as rocks and that we're not going to worry about them.
I feel like there's a big possibility, like what you were saying earlier, Dan, is of like a completely artificial situation where
that's honestly, I think, our only hope, because if you throw a 1 foot diameter boulder in our track, in our path, I don't see us being able to carve through that in any sort of way.
And I know like real boring machines have a way in which the cups retract, and then behind the cups there'd be spinning, diamond cutters, which we're not building diamond cutters.
Yeah, we are not.
We could though.
That's exactly right. The sky's the limit. Okay, so rocks don't exist except for pebbles. Pebbles are real, but rocks, they're not real.
I think we'll easily be big enough to take a couple of small rocks.
Yeah. I think, how do we want to do that actually? What's a good way of, do you want to have a flat plate? So you can have some sort of flat cutting plate, or you can have some sort of like curve in this sense, or you can have a curve that is variable and the position is around the arc. So you could, it's not quite a cam, but
I know, I see what you're saying though, like it rotated and out kind of to adjust the curve.
Yeah, so that you've got a leading edge that is really far out, and then you've got, I can't draw this in 2 dimensions. Okay, give me a second. I'm gonna freaking figure this out. If anybody wants to talk right now, they're more than welcome to talk.
I was just thinking, design of our actual cutting piece is something that I think would be kind of a mid-stage trial and error. Just with creating a test rig and just printing through various designs, because that's something that we're not going to be able to theorize really.
I don't really know if that communicates what I'm going for. But it's basically, it's 2 circles and then you do this, such that you've got places for big cutting. Nah, it doesn't work. I don't think that's good.
I think fixed size is probably the best.
That is just a plane that's rotating.
Or just like fixed size of the cutting scoops.
Sure. Yes.
I think that's maybe the easiest thing we can deal with. Or even what I've seen is like variable size cutting scoops. So, a big scoop comes first and then a smaller scoop in a rotation after that. Like, so alternate scoop and small scoop behind that. So the big scoop would, get any rocks. Whoever's left behind, a small scoop would take care of it, or even alternate curved and then flat.
Yeah, I definitely agree with, I think something more like claws to carve to like loosen up that dirt, but not really peel it out, and then a scoop behind it to actually feed it into the system.
Yeah, I think, or and then even after the scoop, just like a flat plane kind of scooping thing. So you have like a round scoop to get larger material, and then a flat plane to kind of like skim off the rest. I think
Yes,
diversity is our friend in this case, and just having
multiple layers.
most permanent options, so it's just a very diverse cutting head.
Yep. Something like sawtooth or something like that.
Yeah.
Yep. Cool. I like that too. All right, so I need to take a look at a calendar for a second. I am hopefully back home on the 6th, and presumably I have internet access. I'm moving this week and also going camping because I'm going to be homeless for 3 days.
Oh, that's really smart.
Yeah,
that's
it's going to be
really
a good time.
Smart.
And I'll be officially homeless between the 3rd and the 6th, which is very exciting.
I'm going to say about 7th or 14th.
Yours is that's a long one. Yeah.
They're going to be bouncing around between friends.
Yeah. So I think we can do this the same time in a week from now. That'll be the plan, anyways. In the meantime, are there things that people are super interested in looking into?
I'd be more interested in looking into the different cutting methods and digging ideas.
Okay, cool.
I think we should definitely keep all options open for the offloading mechanism.
You mean just however we're getting the dirt out, just keeping it open?
I think that should be, we should really thoroughly go into each method because, and especially since we don't know the exact parameters of the competition. Because I think, we could end up in a situation where maybe just a simple rail is the best and we just don't have continuous. I think there's a lot of scenarios that we just can't predict in that case.
Yeah, I think for now, assuming I think zip or the ski, let's call it ski lift, and just dune buggies or RC cars. Those are the two primary ideas for getting rid of dirt.
Absolutely.
Which one would you prefer to look into, Rob?
I think I absolutely have more experience with the RC cars, but I think I could do a pretty decent comparison of both.
Okay. Then why don't you do the pods and I'll do the RC cars, because maybe I see something else.
Yeah.
God knows whether I'm going to be able to get to that before next Thursday, but that'll be on my docket.
I'm kind of in the same boat, but I'll do my best.
Okay, cool. Ahmed, what do you want to think? We haven't talked to anything about navigating. That's what you were gonna. That was gonna be your baby.
Yeah, I was thinking maybe not even navigating it, but there's a lot of like inputs we're talking about. Like if we hit a rock, if I don't know how to describe it, but I was thinking like sensor intake. So what type of sensors you would need and what the different options for sensors are. To be honest, I haven't, touched navigation too much yet, but maybe we're not at that stage where we need it yet. Maybe it's more of like just sensor intake and what type of sensor values we'll need for those pods and for the actual digging mechanism.
Just so you know, you weren't here when we were talking about this, but there are 3 different criteria, like 3 different, I guess, winners. And one of the winners is guidance and most accurate guidance. So we could exclusively win in that category, even if we don't dig the fastest tunnel.
Yeah, I think you already had that though, right?
Yeah, I knew that. I think the only problem with the guidance is though it's such a complex system that it'll really even depend on what structure we use. Like if you have pods coming in, one of my ideas was just use lasers and sonar. But if you have pods running in the back, you could just do, basically there's a lot of factors, and I think maybe we I'll keep researching it, but maybe we hold a little bit on that and I start with sensor intake is what I'm thinking.
Yeah, I think that's right. Yeah, there's going to be plenty of things that we're going to need to know about. We didn't talk at all about temperature today, but that's probably going to be a consideration. I don't think things should get that hot, but
I wouldn't think so.
But who knows? Good. All right. Yeah.
Sweet.
Yeah. Anything else?
I think that's it.
I'm good.
Sweet.
So
Well,
So we're thinking basically same time, basically a week from today is what we're kind of thinking.
Yep.
Okay, sweet. I'll be sure to put some stuff together about navigation sensors for them.
Cool. Well, I think I'm gonna post this on YouTube. I'm not really sure yet, but we want to keep everything open source so that people can just kind of keep track of what we're doing. And if people want to steal our good ideas, then they're more than welcome to, because we're not going to make any money off of them. So, yeah. All right. Well, it's good talking to you guys. And I will see you next week.
Awesome.
Or tomorrow, if you guys want to come to the outreach meeting, which should be fun, because Cole's going to be there too. So.